Hello everyone, welcome back. Today I'm going to solve for you guys question 25 of the section 15.1, which asks to evaluate this iterated integral. General technique: if you have an iterated integral, you start with the inner one, the results a function of the outer variable, then integrate with respect to outer variable. So in this case, I'm going to do the inner one in this case is this guy, and then the result would be a function of v, and then integrate with respect to v. Okay, let me do this separately. So integral 0 to 1 of v u plus v squared for du. Something that you have to remember is that when you integrate with respect to u, the other variable, which is v, you just consider it as constant. It's just 1, 2, something like that. Okay, then how we are going to solve this? How I can find integral of v times u plus some constant to the power 4. Okay, what I can use here is substitution. I set t to be u plus v squared. V is constant. It's just like 2, 3. And then dt is going to be du. Then also about the boundaries, when u is equal to 0, then my t is equal to v squared. When u is equal to 1, then my new variable, which is t, is going to be 1 plus v squared. Now my new integral is going to be v squared from v squared to 1 plus v squared, v t to the power 4, du is equal to dt. So we have this. V is constant. Just take it as constant. Then the result is going to be v times t to the power 5 over 5. That's just power rule for integrals. Then I have to change it from v squared to 1 plus v squared. And the result is v times 1 plus v squared to the power 5 over 5 minus v times v to the power, let me do this way, v2 to the power 5 over 5. So the result, I can write it here now, because everything is in terms of v. It is v over 5, 1 plus v squared to the power 5, minus that part is v to the power 11 over 5. Okay, this part is now easy integral. So let me write that first. V to the power 11 over 5 dv. I separate the integral, so I have minus sign there. The other one is v over 5, 1 plus v squared to the power 5 dv. And both of them go from 0 to 1. Okay, so I'm going to do this integral separately, each one. The first one here is just power rule. I have v to the power 11 dv, so antiderivative of that is 1 over 11 plus 1, which is 12, v to the power 12, going from 0 to 1. And that is going to give me negative 1 over 60, 1 to the power 12 minus 0 to the power 12, which is minus 1 over 60. So that's first integral. I have the result for the first integral. For the second one, okay, let me call these guys 1, 2. I found 1. Now time to find 2, which is integral v over 5, 1 plus v squared to the power 5 So this is a very good example to refresh your integration techniques. Here, what we have is 1 plus b squared to the power big number, which is 5 here. Whenever you have such situation, look for the derivative of inside the bracket. Derivative of 1 plus b squared is 2b. So if I take new variable, my new variable to be 1 plus b squared, then my ds is going to be like that. Okay, you may say, where is this 2? I can't get rid of that 2 by dividing by 2 there. And other thing would be, I have to change the boundaries. So if v is 0, s is going to be 1. If v is 1, s is going to be 2. So I can rewrite this integral completely in terms of s, which is from 1 to 2. These guys together give us half of ds. And this guy is s to the power 5. So I have this integral, which is again easy integral because, oh, I forgot to put 1 over 5 down there, so let me just put 1 over 5 because it is just there. I just put it down there. So now I have 1 over 10 times integral of s to the power 5. That's power rule, which gives me s to the power 6 over 6 going from 1 to 2. So going from 1 to 2, that is going to be 1 over 10, 2 to the power 6 over 6 minus 1 to the power 6 over 6. And together, I'm going to get 60 to the power 6 is 64 minus 1 is 63. So integral 1 was negative 1 over 60. Integral 2 is 63 over 60. So then the result, the whole thing is going to be minus 1 over 60 plus 63 over 60, which together is 62 over 60. Again, remember, iterated integral is nothing but a regular integral. You do the inner one, then do outer one. Thank you.